This presentation is in two parts. We start with a little bit about Meesho and the story of our growth, what we deliver to our customers and our sellers, how we operate, and how the journey has been so far. And the second part dives into some of the technology aspects of how we have managed to sustain this growth. And particularly, we'll see Redis in action. Specifically, I'll touch upon some of the topics that Itaf was mentioning around how Redis is much more than a cache, and focusing on the versatile use cases and some of the cool things that we have done there, and close with a sneak peek of how the AI/ML stack looks like at Meesho. Okay. So starting off with our mission statement, we are here to democratize internet commerce for everyone, right? So what does that mean? What does for everyone mean? Right now we are focused on the Indian market. So for all of the billion Indians, how do we make internet commerce a reality? And that's what our immediate goal is. And just to highlight that point, if you look at the internet population in India today, we've crossed, I think, over 600, 700 million in users of internet in India. But if you look at people who actually shop online, that's a very small fraction of that massive internet user base. And the question is, what stops at least the next billion users, as they call them, or the Bharat users? What stops them from shopping on the internet? And first, I think, first and foremost, one of the key things is about affordability, right? And if you look at most of the online commerce destinations, they sell predominantly branded goods. And branded goods, by definition, come at a premium. And that premium is out of reach for majority of India, right? Majority of Indians are still shopping from their neighborhood stores, and they care about, they're extremely price sensitive, right? So Meesho is bringing all of the selection available in the neighborhood stores, all of the unbranded goods, and providing a gateway for selling unbranded goods online, right, at the best possible price. So best prices and a relevant assortment. These are two vital pillars which are key to the value proposition that Meesho is delivering to its customers. The other thing which is equally important is, if you look at the Bharat user, a lot of them are new to the internet, right? So their technology adoption curve, so to say, is on the lesser side. In terms of the user interfaces that they prefer are quite different from the mature internet user that all of us know of. And if you look at one of the key characteristics, and this has been talked about in literature as well, that the next billion user is not very savvy when it comes to doing search, right? They can't find the right keywords to search for their needs on the internet. And using a feed, a browse-led interface, comes much naturally for them. So they can keep scrolling an infinite feed to serendipitously discover content, and in the context of Meesho products, right? So Meesho delivers a very, very intuitive user experience, which is majorly browse-led through these infinite personalized feeds. And we are also getting into voice search and search with visual with images, which again simplifies the search metaphor for this particular user base. If you come to our sellers are very different again. right? Compared to the sellers which sell on other large e-commerce platforms. And if you look at majority of the sellers, they are also new to the internet. They are new to selling on the internet. So they were selling offline in neighborhood stores. These are very, very small businesses, less than 5 employees, selling majorly unbranded selection, right? 60% of the selection is under 300 rupees, which is like 3.5 to 4 US dollars, which is a price point which is like one could probably not imagine that could be sold online in a viable manner. And Meesho is making that possible. And how is, so this just touches upon the value proposition to our sellers. If you look at the challenges faced by our sellers, they of course were limited to selling offline. That limits the total footfall and their reach. They could not sort of list in a lot of the established e-commerce platforms because the cataloging process is too complex, it's too expensive. They operate with razor-thin margins, which makes paying commission to an e-commerce platform extremely not viable, right? And how is Meesho changing all of that? We have extremely simplified cataloging process. So all that you need to do is click photos of your products with your handheld cameras, upload them, and within a few clicks, the product gets ready for orders on Meesho. And we operate with a 0% commission model, right? And that really opens up the platform to a very, very large set of sellers, and they are selling online today thanks to Meesho. And what enables us to do all of this is a zero inventory model. So our e-commerce model is fundamentally different from the way the other platforms operate. They operate with a warehouse-led model. We operate without a warehouse, right? So what happens is once the seller uploads the product images and lists the products on Meesho, the orders start coming through. When an order comes in, there's a third-party logistic partner which picks up the product directly from the seller and ships it to the buyer, right? So there's no warehouse in the middle. We do not own logistics arm ourselves. And all of this makes the Meesho business model very, very lightweight. And we can, because of lack of overheads in our business, we can pass the entire price benefits to our customers. And as we said, the seller takes up all of the sales volume without any commission, right? And so the golden question is, how do we make money? How do we sort of run our business? And the primary revenue source is that of ads. These are product listing ads. So when sellers want to increase their reach, increase their orders on our platform, they can make use of some of these product listing ad slots where they can opt in to get greater sales through traditional cost per click kind of campaigns. Right. A few words on the opportunity. The opportunity is actually massive, much, much higher than the opportunity of branded commerce. I think India's commerce GDP is a little less than $1 trillion. And majority of India's commerce is today unbranded, right? 60, 70, 80% would be unbranded. So that's the opportunity which is much, much larger from the total TAM of what branded commerce can deliver. And the reason to all of that, in the last 3 years, thanks to the execution from the team, we have been growing phenomenally, over 100x since 2019. We are currently valued at $5 billion. We recently concluded our best ever festive sale with over 33 million orders over 5 days. So with that, I come to the next section of our talk, and which is around technology. And the first part is we've been able to support this great scale and the hyper growth thanks to our fabulous engineering team. And a few stats over here. 30 ms is the average P99 latency across all of our APIs, right? So that means that majority of all of our backend APIs are operating at an incredible real-time latency. 1 million peak requests per second is handled by our experimentation API, right? So that gives you a flavor of the massive scale that the platform is seeing, and thanks to partners like Redis, we are able to sustain that scale. Right, so what I'll do next is I'll give you a flavor of how our technology stack is structured, right? And then I'll get to some of the Redis use cases. So overall, at Meesho, we have a layered microservices architecture to sort of constitute our backend. So what that means is, if you look at the different layers of microservices, so the clients, which are our customers, our sellers, and our internal ops teams. So the customers are discovering products and placing orders through our Meesho app and the website. The sellers are listing products and changing prices, changing inventories through the seller app, as well as there's a web portal as well. And then there are merchandising operation teams within Meesho who are sort of controlling all the real estates in the Meesho app and website. Right, so, and all of these clients or the applications that these clients are using, they are invoking different backend APIs. And the first layer that they hit is the API gateway layer, which is again roughly broken down into 3 parts. The storefront is on the discovery side of things, where the customer and the shopping experience hits this particular layer. Then there's a merchandising sort of a component, and then there's a supplier set of APIs. And the API gateway layer next sort of calls the next layer of services, which we call composite services, which if you again see like roughly broken into 2 parts. One on the customers and the product discovery side, you have services for powering the product feeds, their product aggregation, so I'll talk about this particular service. There's transaction management for managing the transactions, lots of widgets and merchandising operations on the e-commerce platform. So there's a widget aggregator service. And on the supplier side, you have things for cataloging, for managing ad campaigns, for like maintaining the post-order workflow. And then that layer sort of in turn calls another layer of what are core services. These are the entire gamut of services, and there are many, many more, but I've sort of listed out some of the more important pieces here. Again, ranging from the discovery side on the feed personalization, search, managing reviews and ratings, to the supplier side where you manage taxonomy, to the order processing side where you manage orders, you manage frauds, and all of that, right? And the bottommost layer is what we call the infrastructure services layer. This is a platform services which sort of puts in wrappers on top of core databases and technologies that our developers use, so that we can maintain a lot of the access to some of the core infrastructures that we use in a flexible manner. And there's experimentation platform also there, an ML platform. We'll touch upon some of that later. So next up, what I'll do is we will pick some specific examples of how Redis has been used in a versatile set of use cases across each of these layers, right? So what I've done is we have picked one example from each of these services layers just to make a point that Redis is not a cache. I mean, if it's a cache, you would think that it's sitting at the bottommost layer and you have a wrapper on top of Redis, which everyone else is using. And it goes far beyond that, right? It is very, very tightly knit, is almost central to many of the applications in the different services across the layers. Right, so we'll start with the topmost layer, which is the API gateway layer. So we have designed a rate limiter, which is a common use case in any API gateway, where the use case is to set limits on the number of requests that arrive from a particular client, which is identified by URLs and headers. Right, and our Redis, so our design uses Redis, where we store incremental logs for each of these requests in real time in Redis, right? And then, so the way it's done is there's a client ID and you store all the logs in terms of counts and timestamps for these requests in the value. And there's a distributed locking mechanism which is sort of implemented again using Redis, where you take a lock on the Redis key to maintain consistency in writing these request logs, right? So the entire design of this rate limiter is sort of backed by Redis, right? And the distributed locking implementation is also used across many of the services, including transaction management. The next example is around the product aggregator, which is from the next composite services layer. And this is a more natural use case for Redis. Redis as a read-through cache. But it's interesting that the read-through cache is not fronted by a database. It is actually sort of backed by multiple microservices, which are the ground truth which are serving the ground truth for different product attributes, right? So if you think about a product, it has a variety of attributes from price, color, and so on and so forth. And many of these are coming from different services. So the price comes from a pricing microservice, the cataloging information comes from a different microservice. And when you're hitting your discoveries, let's say there is a feed request, one would need to return a set of products, and along with the product IDs, they would need to return all the metadata, right? And for every feed request, if you aggregate and fetch all the product metadata, that would not scale, right? So what we do is we take a design choice of availability over consistency, where we put in this aggregate layer where all the product metadata is cached for a period of 5 minutes, right? Upon cache miss, all the attributes are then aggregated from the different downstream core services, right? And again, the implementation is with a Redis edge set. So I'll get to the next one. The next one is one from the core services layer, and that of a product feed service. And this product feed service serves a non-personalized ordering of a given product collection, right? So let's say a red shirt is a product collection. You need to return a non-personalized ordering based on popularity of those products. And there are two use cases that I'll talk about and how Redis powers this particular service. The first is pagination, right? So you design pagination using Redis, where you actually store a version of an ordered version of that particular feed in Redis, and that is cached for 5 minutes, right? And we ensure that every user is served pages from the same version, so that the same product does not get repeated across pages of the same feed fetch, right? The other thing is we scale this particular service by queuing and collapsing feed requests. So essentially what we have done is the feed creation part and the serving part, serving the request, these two are decoupled, right? And they are stitched together in an async manner, where the entire async message processing unit is designed with a combination of a Redis Z-set and a Redis list, right? So it's another cool novel application where a pub subsystem has been sort of implemented ground up within a service, and it's helping it scale by queuing and collapsing feed requests, right? Another one, this one from the bottommost infrastructure services layer, one from our experimentation platform. And here the use case is of audience management. So what are audiences? Audiences are these lists of user IDs which get created, which get often used for running campaigns and running experiments. And the requests that we serve in this particular use case is you need to return the list of audience IDs out of a given list of audiences, where you need to choose which are the audiences where the given user is a member of, right? And what we have done to efficiently, like if you think about this particular use case, there is a list of audiences which the user belongs to. Now, given a new list, you need to check which are the audience IDs which the user belongs to. It's like an order of n operation, right? And like I just said, our experimentation platform operates at 1 million requests per second, right? So we need to do much better than order of n. So we maintain these bit sets, right? And to maintain users' membership to different audiences. And to serve this particular request, all that you need is a bitwise AND operation, right? So to do all of this operation in constant time. And so that's another cool little application of how Redis data structures can help us scale systems very, very efficiently and scale these services to massive scale. Okay, just before I close, I don't have a lot of time, but I'll give you a sneak preview of the AI/ML stack, the team that I represent. So if you look at AI is powering pretty much a very wide variety of applications. Every pillar of the e-commerce platform, you can think of a use case and a service which is being powered by AI and machine learning. Right from the demand side, for all of your feed personalization, homepage, widget personalization, search, like doing semantic search, understanding vernacular queries, all of this is being done by AI models. All of our recommendations. Then on the user growth side, you have notifications, monetization has ad relevance. On the supplier side, I mentioned we have an extremely simplified cataloging process. Much of that is being powered by computer vision, right? On the fulfillment side, can you predict that, hey, this order has a chance of getting returned, so you may need some additional actions, so return prediction and fraud detection, all of these are applications which are making our fulfillment process much more efficient. All of these applications are sitting on top of a range of capabilities where we are deeply invested and trying to further the state of the art. And all of this is sitting on top of platforms. And again, this is the platform layer which Jack was talking about. And many of these components, Redis is very tightly integrated with these platforms. We have a very large-scale feature platform which operates at massive scale and at very low latencies, and many of those feature stores are built on top of Redis. We have a massively scalable vector search engine, a model inference platform, platform for observability. Right? So that's about it, and thank you so much.